Welcome to the Mole Notes Part 2. This is what we're doing on January 5th, the Friday. It was an A day. And so we're actually going to dive into, okay, what is the mole? We've calculated molar mass. It's the title of this unit. Everything. I'm seeing the mole, the mole, the mole. What is it? Well, the mole means a pile or a mass. So really, all it's doing is it's a unit that chemists use to measure the amount of something. And you might be asking, well, why don't we just use grams? Or why don't we count everything in atoms? Well, sometimes grams and atoms both can be way too small of a number for what we're actually wanting to use. And so the mole is the SI unit. And remember, SI is just the symbol for a Greek word that essentially means the standard or international unit, the unit that chemists all over the world use for the amount of a pure substance. Okay, so it's just talking about purely NaCl, purely chlorine, purely sodium, just whatever your substance is, it's only that, containing the same number of chemical units as there are atoms. Okay, so it's exactly that number of atoms in exactly 12.000 grams of carbon-12. So what they did was they took carbon-12, which remember, if you look at carbon-12, that means it has 6 protons and 6 neutrons, because 12 minus 6 is 6. So they took 6 protons, 6 neutrons. They figured out how much an atom of carbon weighs, and then they discovered how many atoms were in exactly 12.00 grams of it, and they compared every other substance to it. They said, okay, exactly how many atoms is that going to be? And so what that means is the number 6.0 times 2 to the 23 is known as Avogadro's number. Avogadro was this Italian scientist named Amadeo Avogadro, and he determined that number. He determined that in 12.00 grams of carbon-12, there existed 6.02 times 10 to the 23 atoms of that carbon. And so we can use this to say a whole bunch of things. We could say that 1 mole of carbon is equal to 6.02 times 10 to the 23 atoms of carbon. We could say that 1 mole of marshmallows is equal to 6.02 times 10 to the 23 individual marshmallows. I could say that a mole of basketballs is equal to 6.02 times 10 to the 23 basketballs. Okay, and all of these things, it's just a simple unit that scientists have created to represent that number, so that instead of using a number that has a scientific notation and is really big, we get to use whole numbers and simple numbers that are easier to do math and to write down and things like that. And so we use the mole in the same way we would any other unit. When we look at socks, we talk about a pair of socks, and a pair of socks is referring to 2 socks. You have 1 pair is always equal to 2 of whatever it is. If I have a pair of socks, it's 2 individual socks. If I have a pair of sunglasses, then I have 2 individual sunglasses. If I have a pair of chickens, then I have 2 chickens, right? Or we might be talking about a ream of paper. Now, 1 ream is equal to the number 500. Okay, just so a ream of pencils would be 500 pencils. Okay, or we might say that we have a dozen eggs, right? And we know that 1 dozen is always equal to 12. If I have a dozen cookies, it means I have 12 cookies. Okay, so that unit just represents that number. And for a mole, okay, we know that a mole of salt would be 6.02 times 10 to the 23 formula units of salt. Now, the key thing is that word formula units. Okay, I know you've heard it before, but I do want to go over something really quickly to make sure we all recall this. Now, you can have 3 different types of substances, okay, in chemistry class. You're going to have ionic compounds, and I'm just going to abbreviate the word compounds. You could have covalent compounds, and you could also just have plain old elements, okay? Now, this is important because each one will have a different unit that goes with it. So ionic compounds go by or use the word formula units that you see here. So this tells us that salt, otherwise known as NaCl, is ionic because it used the word formula units. We have a metal, sodium, and a nonmetal, chlorine, so we know it's ionic. Covalent compounds use the word molecules, so it would not be appropriate to describe any word or any substance that's not covalent as a molecule. And then when we're talking about individual elements or individual units of an element, we're talking about individual atoms themselves. And so we could say that Avogadro's number, 6.02 times 10 to the 23, could be really anything. It could be 6.02 times 10 to the 23 particles. And we could use the word particles as just the sciencey word for things. It could be anything. I could have 6.02 times 10 to the 23 Chick-fil-A sandwiches, and then I would have 1 mole of Chick-fil-A sandwiches. In fact, with how large those are and how large that number is, that would probably be enough Chick-fil-A sandwiches that it would fill the entire world. So that would be quite a lot of sandwiches. So if we keep going, okay, we have just a bit of molar mass notes and practice, which we've already gone over, but just to remind ourselves that molar mass is the mass of 1 mole of any pure substance, and the units are grams per mole or grams per mole written this way, and that slash is said as per, so grams per mole. And so it's the atomic mass of an element or the molecular mass for covalent, again, molecule, covalent, or formula mass for ionic, formula unit. Okay, and when we're looking at molar masses, 1 mole of lithium would be equal to its atomic mass because lithium is an element. And so that would be 6.94 grams of lithium. I just pull it straight off the periodic table. Now, oxygen, however, is a little bit of a different story. I don't have just 1 mole, or I don't have just 1 oxygen atom. Remember, oxygen is covalently bonded when it's diatomic, and its Lewis structure looks like this. And so that means it's going to be a covalent compound, but both oxygen atoms are nonmetals. So that means I'm looking for its molecular mass or molar mass the way we calculated it in part 1 of the video. So if each oxygen atom is 16 grams, and I have 2 of them, that would mean that I have 32.00 grams of oxygen here. And so that is something that we keep in mind. And so you can calculate your molar masses for the next 2 bullet points on your own. Now, when we're looking at this chart, okay, we want to decide what the formula name is. And so when we're looking at sodium chloride, we know that sodium chloride would be NaCl. They both have a positive 1 and negative 1 charge respectively, so there's no need to cross and drop. And in terms of particle types, we know that sodium chloride, sodium is a metal, chloride is a nonmetal because it's referring to chlorine, and so that means it's ionic, and it will be using formula unit. And if we were to calculate the molar mass, we have 1 sodium plus 1 chlorine, and that would give us 58.44 grams per mole. And so what I want you to do is go ahead and practice through this, and you can check your answers with me in class. Now, if we're looking at this next chart, which I hope you paused the video and completed the previous one, and we're looking at the substance, their molar mass, and the number of particles in 1 mole. What I'm going to do is I'm going to go ahead and just write through the formula. So carbon is a C, gold is AU, sodium nitrate is NaNO3, sulfur dioxide, SO2, and argon. Okay, now remember, I hope not all of your skills are gone, cheesy pun, because you need to be able to convert from names to formulas in a matter of seconds if you want to be able to be successful on these tests and be able to complete them in a timely fashion. So we can go through and we can count the molar or calculate the molar mass for each. If we look at carbon, we know that carbon has a molar mass of 12.01 grams per mole. And if we look at gold, gold has a molar mass of 107.87 grams per mole. If we look at sodium nitrate, we're going to have a molar mass of 85.00 grams per mole. And I get that by determining the molar mass of sodium, nitrogen, and my 3 oxygens and adding them together. And I'm going to let you do the remaining 2 on your own. But the key thing about this is regardless of the mass, the molar mass, the number of particles is always going to be the same. The number of particles is Avogadro's number. So 1 mole of carbon always has 6.02 times 10 to the 23 atoms in it. Whereas gold is also going to have 6.02 times 10 to the 23 atoms in it. Now, clearly, they don't have the same mass. That's because they don't have gold and gold and carbon have different numbers of protons and neutrons in them, which contribute to their mass. So even though you're going to have the same number of atoms, those atoms are made up of different subatomic particles. And so while their molar mass is different, the number of particles in them in 1 mole of that substance remains the same. And so if we look at sodium nitrate, again, I'm going to have 6.02 times 10 to the 23. But now instead of talking about atoms, I know that sodium nitrate is an ionic compound because I have a polyatomic ion, I have a metal, and so I would be referring to 6.02 times 10 to the 23 formula units. Okay, and we can use the same logic to do the remaining portion. And so if you look at your conversions, we see that 1 mole is going to be equal to 6.02 times 10 to the 23 particles. And again, remember, particles could be atoms, it could be molecules, it could be formula units, it could be individual ions. If I wanted to know about the number of particles in, for example, NO3 minus 2 nitrate, specifically that ion, 1 mole could also be equal to the grams of the formula weight, so aka our molar mass. And something else that Avogadro, I believe, discovered is that 1 mole of any substance is always going to take up 22.4 liters of space. And we're going to use these unit conversions in our next class.